Base catalyzed ring opening of epoxides. What are epoxides? Epoxides are cyclic ethers. Cyclic ethers in which oxygen is bonded to two adjacent carbon atoms. This is simple epoxide. Now we are going to discuss base catalyzed nucleophilic substitution or base catalyzed ring opening of epoxides. Base catalyzed ring opening of epoxides. This always follows SN2 mechanism. This always follows SN2 mechanism. Now let us take one epoxide CH2C CH3 CH3. This epoxide I am taking now. Now this should undergo a ring opening in the presence of base. So with approach of nucleophile, what happens? The bond pair that is there on this will move towards oxygen, or nucleophile attacks from less sterically hindered side because it is SN2 mechanism. So what will I get? CH3 CH3 O minus, and here CH2 nucleophile. Now it reacts, it takes H plus ion from the solvent because it is base catalyzed. So what will I get? CH3 C CH3 OH here CH2 nucleophile. This is anti-addition. So again I am repeating, base catalyzed ring opening of epoxides follows SN2 mechanism, always follows SN2 mechanism. As I already discussed, if it is acid catalyzed ring opening, it follows SN2 mechanism if both the alkyl groups of epoxide are primary or secondary. It follows SN1 mechanism if one of the alkyl group is tertiary. Again I am repeating, if one of the alkyl group is tertiary and if the reaction is acid catalyzed, ring opening follows SN1 mechanism. If it is base catalyzed and one of the alkyl group is tertiary, then ring opening takes place by SN2 mechanism. Whether primary, secondary or tertiary alkyl groups are there, if it is base catalyzed, the ring opening always follows SN2 mechanism and it is anti-addition. Now let us take one more example. Before taking one more example, I am explaining, repeating there. If acid catalyzed, if an epoxide is like this, I will take one example. This is epoxide I am taking. This is the epoxide I am taking. Okay. One alkyl group is tertiary and one alkyl group is secondary. And if the reaction is catalyzed by acid, if the nucleophilic substitution is catalyzed by acid, it follows SN1 mechanism. Means the nucleophile attacks tertiary carbocation. So tertiary carbon, the nucleophile attacks tertiary carbon. So what will I get? CH3 OCH3 here, because this is a tertiary carbon. CH OH CH3. Because it is acid catalyzed, it is following SN1 mechanism. Now let us see if it is a base catalyzed reaction. CH3ONA and CH3OH. The nucleophile is OCH3 minus here. So what is the product obtained here? If it is base catalyzed, the product obtained will be this one. The product obtained will be this one. Means the nucleophile is attacking less hindered side. So the mechanism is SN2 here, and here in the above case, when it is acid catalyzed, the mechanism is SN1. So if it is a tertiary, one alkyl group is tertiary in epoxides, then If the reaction is acid catalyzed, ring opening follows SN1 mechanism. If the reaction is base catalyzed, ring opening follows SN2 mechanism. But both the addition